Everyone, we're just going to do a quick set of questions from the foundation paper of the AQA exam board for GCSE maths. Let's start with the first question here. It says, circle the answer to the calculation 0.34 times 10. Let's write this down. Let's see if we can actually write this down properly on here. Okay. 0.34 times 10. Okay, the rules we need to think about in these kind of questions. When you're multiplying or dividing by 10, you just need to move the decimal point. If you're multiplying it by 10, you move the decimal point once to the right. If you're dividing by 10, you move the decimal point once to the left, okay? And in fact, any number, any, greater number, like for example, 10, 100, 1,000, and so on. If you're multiplying by that number, you move the decimal point the same number of times as there are zeros. So if, in this case, we're moving it once to the right and one time because there's only 1 0, okay? So let's maybe change color here. It's going to go right there, yeah? So the answer for this one would be 3.4. That should be one of the answers on the actual question here as well. It did say to circle the answer in the actual question. Yeah, 3.4 actually is one of the options there, so that's correct as well. Okay, for this question, we're asked to find which shape is congruent to shape A. So have a look at these shapes quickly. You'll see that shape A itself is got a big circle on the left side here next to number 2, which is for the second question. We're going to change color to red. Now B looks nothing like A. Congruent basically means that it's the same shape, right? Irrespective of orientation of the shape itself. So as you can see, shape B, C, D, and E are all orientated differently, okay? But they're also different shapes, most of them, except one. So if we look at, let's look at B, for example. B has 4 blocks going down and one on the left. But we don't need these 4 blocks. We need 3 going down, 1 left, 1 right. So B is wrong. Okay. Let's look at C here. So C, there is 3 going down the length of the shape, 3 blocks. There's also 3 here. There's 1 in the middle going downwards. There's 1 in the middle here going off to the left. And there's 1 at the end going upwards. And there's 1 at the end going right. We can turn this shape A into shape C, I believe. Let's see. If we do this, if we rotate the shape 90 degrees anti-clockwise, so 90 degrees, oh god, 90 degrees anti-clockwise, this would be, it will look like this. Something like this. Okay. Now this looks similar to shape C, except the block going up is on the other side. So what we can now do is we can reflect this shape, okay, through here. This isn't a line of symmetry, by the way. But if you flip the shape over through this line, you get this. I need to go back 1 sec. I need to undo that. Okay. So we'll get this. Which is basically the same shape as C, if that makes sense. So C, That means this one is correct. So D is obviously going to be wrong. It looks nothing like shape A. And obviously E is going to be wrong. It looks nothing like shape A. So the answer for this question is going to be C. So just to recap quickly, congruent shapes is everything to do with the size of the shape and the shape itself, the overall shape of it. Okay. It's nothing to do with the orientation of the shape, as we've pointed out here. Okay. Let's write this down. Let's write down some notes. Okay. Congruent shapes have the same. Let's also underline some keywords. Keywords being same. The same number of sides and are the same size. Keyword same again. Size. Okay, in this question, we're asked to circle the fraction that is not equivalent to 4/7 or 4/7. So the topic of this question and what we need to really do is look at our fractions that we've been given, and we need to find common factors in each fraction, ultimately reducing the fraction to 4/7 or reducing it to its simplest terms. Okay. So let's start with the first one. So we have 10/14. We're going to find a number that goes to both 10 and 14. Okay. Let's change color here as well to, let's go purple this time around. So a number that goes into 10 and 14, if in doubt, just always half the number and then work from there. So in this case, we're going to divide by 2 for both, because 2 can go into 4, 2 can go into 0. Well, a number that ends in 0 anyway. So 2 into 10 is 5. So let's write down here 10/14 equals 5 over, and 2 into 14 is 7. 5/7. And this can't be simplified any further because 7 is a prime number. Okay. So this is one of them. We're going to circle that. I know it says circle this, but we're going to change color in the end and we'll highlight the answer more clearly as well. So that's that one. 12/21. Let's have a look at this. 12/21. Let's put a comma there. So what number goes into 12 and 21? Well, we can say 3. Yeah, because 3 can go into 12 and 3 can go into 21. So 3 goes into 12 4 times. 3 goes into 21 7 times, sorry. Oh, and look, and as we can see here, it's exactly what they want. Yeah. So this actually will be your answer. We're going to also underline this in red to show that this is the overall answer. But let's go ahead and simplify the others whilst we can. So 16/28. Well, again, if in doubt, just half the numbers. So 2 into 16. By halving, what I'm saying really is we're using 2, okay, to divide into these to begin with. Then we can simplify further. So 2 into 16 is 8. And 2 into 28 is going to be 14. This can be simplified further. We can use 2 again. So 2 into 8 is 4. And 2 into 14 is 7. Oh, so look at this. This is actually, oh, hang on a sec. Let's reread the question. Circle the fraction that is not. Okay, so let's go ahead and, well, first of all, let's go and rub out our answer, because this actually is not the correct answer then. Let's go ahead and put a red here because this is a keyword. Not equivalent. Always make sure, guys, that you read the question carefully in your exams. So not equivalent to 4/7. So this is equivalent, this is equivalent, this is not equivalent. So this is going to be your answer. Okay. But let's double check in case there's others, in case this one might be one, the 24/42. So let's change there as well. Put a comma here. So 24/42. Again, as I said, if in doubt, just half it. But what we're going to do here is yeah, let's half it. We're going to half it to be keeping things simple and just we have a lot of space so we can simplify further. So 2 into 24 is 12. And then 2 into 42 is 21. And what numbers can give us 12 and 21? Well, we got to be careful because there's a 21, so we're not going to use 2 again. 3, because 3 can give us 12, so 3 4s are 12, so that's going to be 4. 3 into 12 is 4. 3 into 21 is going to be 7. And this is, again, prime, 7's prime, so this is as further as it can go. So let's circle this as well. So yeah, it shows then that 24/42, 8/4, 16/28, and 12/21 are all equivalent to 4/7. And it shows that 10/14 is the only fraction amongst this, amongst these fractions, which is not equivalent to 4/7. So the answer is going to be 10/14, which is going to be this one. So they mentioned to circle it, so we're going to circle this. All right, in this question, we're asked to simplify 4x minus, open brackets, 2 minus 3x, close brackets. Now, what we're going to need to do is we're going to have to use BODMAS operations to work this out. Now, BODMAS governs every maths operation you do when it comes to actually solving questions and equations and expressions, okay? So let's first start by denoting what these operations are. We have B, I'm going to call it O this time, BODMAS. Oh God, put the S there. Okay, there we go. Yes. So B is going to be brackets. O is other, or as most of you guys would know nowadays is indices. D is division. M is multiplication. A is addition. And S is subtraction. Okay. Change to red to work this one out. In fact, we'll change to green. Okay. So first things first, brackets. Do we have brackets? Yes, we do. We have brackets here. But there's nothing to really work out inside the brackets because the brackets themselves, you can't do 2 minus 3x because x, we don't know what x is. If it was 2x minus 3x, then you could do that. Yeah. If it was 2a minus 3a, you could do that. If it was 2 minus 3, you could do that. But this is 2 minus 3x, where the x is attached to the 3. So that is, there's nothing really to do there. Okay. What you can do is if you look at the bracket itself, this minus in front of the bracket is the same as saying -1. Okay. Whenever you have a minus followed by a bracket, you should treat it as -1 times that bracket. And what it basically means is wherever the sign is outside the bracket, if it's a negative sign outside the bracket, every sign inside the bracket will change to its opposite. Okay, so in this case, we're going to have 4x. Let's get the x properly done here. Yep, 4x. We're going to have minus, we're not going to have the bracket anymore. So this +2 becomes a -2. So it's going to be -2. And minus times minus is plus. Yeah, because remember it's like -1. Let's put the 1 here to be safe so everyone's aware. There's a little imaginary 1 there. So -1 times 2 is -2. -1 times -3. Let's go ahead and put some curly lines as well. There you go. -1 times -3 is going to be +3. So plus 3x. Because remember, the x is attached to the 3. Okay. Now, we can do the next stage. So this is the first step. This is your next step. Let's do some more BODMAS or BODMAS. No brackets anymore. There's no indices, so there's nothing other, no powers. No division, everything. There is multiplication inside these x's. There's no division. Okay, multiplication. There's nothing to do because there's no actual multiplication going on right now. So that's fine. Addition. We could do the addition 4x and there's a plus 3x. This is what you call collecting like terms, guys. Yeah. If it was 4a minus 2 plus 3a, you do the 4a and the 3a together. Yeah. If it was 4x minus 2y plus 3z, you couldn't add any of those together because they're different letters. Okay. So in this case, we have the same letters. This is what you call like terms. So we're going to say 4, and because it's a positive 3, it's going to be 4x plus 3x, which is going to be 7x. So 7x minus 2. Okay. Is there anything else we can do here? No, there isn't. Yeah, because we can't take away -2 from the 7x because we don't know what x is. We could assume if x was 1, 7x would be 7 because 7 times 1 is 7. Then when you -2, it's going to be 5. However, if x was 2, you're not going to get the same outcome because you have 14. 7 times 2 is 14. -2 is 12. That's not the same as saying 5. So this is what your answers are going to be: 7x minus 2. Right. So this question now, again, non-calculator paper foundation AQA. This question, sorry, is asking us to estimate the answer for this fraction. Okay. Now, since it is a non-calculator question, the best thing to do, especially since it's asked us to estimate, that's the proof is in the pudding. It's helping us a lot there. Let's underline the word estimate first of all. Now, as long as you estimate and you're consistent with your estimation, then you shouldn't have a problem with answering this question. Okay. So let's start from the beginning. So we're going to have 7.93. Let's do estimate basically means rounding. So we can take 7.93 and we can round this, let's say, to the nearest 10. You know, you've got 7.93, you've got 12.1, you've got 3.86. How about the top part? We can round to the nearest 10, and the bottom part we can round to the nearest 5. Okay, so 7.93 to the nearest 10 is going to be 10. So we're going to say 10 plus, and 12.1 to the nearest 10, we could say 10. Over 3.86 is very close to 5, because if we're doing it to the nearest 5, we're looking at 2.5 on either side of this number. And this is closer to 5 than it is 0. Yeah, because it's 0 to 2.5, anything up to there, or sorry, 0 to 2.4, 2.49 will make you round down, and anything from 2.5 upwards to 5 or to 2. Let me start that again. Let's start that again. So this is going to be over 5. 3.86 is closer to 5 than it is 0. Okay. And now this is much easier to work with. So we have 10 plus 10, which is 20. 20 divided by 5. I'm hoping you guys all know it's 20 divided by 5 is 4. Divided by 5 is 4. And that's your answer. So in this question, Sarah says these two fractions, this decimal and this percentage are all equivalent. Sarah is incorrect. Which one is not equivalent? Okay. Now in this question, we need to just compare our fractions and our percentages. There's no decimals, is there? There apparently is a decimal there. There is a decimal, they're saying. Okay. So we need to compare the three together, and we need to find out, as it says, circle the one that's, or rather, it's asking which one is not equivalent. So let's start by maybe getting the keywords out. The word not. This is very important. So we need to find, so two of them are the same, and one of them is the odd one out, basically. Let's go to another slide here, and let's put these on a new screen. So we have 4 over 8, sorry, 4 over 5, 8 over 10, and 8%. So we're going to have 4 over 5, 8a over 10a, and 8%. Let's double check to make sure these are correct. Yep, that's fine. So let's have a look here. So 4 over 5, already, this, if we were to, this is already in the simplest terms. Let's go ahead and use green here, or blue even. Let's make this a decimal. So 4 over 5 is the same as saying 4 divided by 5. Okay, so we're going to use bus stop method to get this done, just to show you guys the process of doing that as well. So we're going to have 4, and we're dividing by 5. So 5's going into the bus with 4. 5 into 4, 5 is too big, so we're going to put a 0 here. 0 times 5, we'll do long division, but to solve this, by the way, guys, yeah? 0 times 5 is 0. Let's bring it down. 4 minus 0 is 4. Introduce a new 0, put a decimal point here. Bring down the 0. 5 into 40 is 8. 8 times 5 is 40. 40 minus 40 is 0. This ends the calculation. So 4 over 5 is actually going to be 0.8. 4 over 5 is 0.8. Okay. Let's look at the other bit. So let's put a box around this. 8a over 10a. So 8a over 10a. Let's change color for that just to make it a bit more appealing and easy to understand. Do this in green. 8a over 10a. Well, we're dividing 8 and 10, and we're dividing a and a. So a divided by a is just going to be 1. So these can cancel with each other. So this becomes 8 over 10. A number that goes to 8 and 10, we can just pick 2 for now. 2 into 8 is 4. 2 into 10 is 5. Okay. And as you see here, from the very first one, 4 over 5 and 4 over 5. So this is definitely going to equal 0.8. Okay. Change color now to purple. So we already know straight away that the odd one out is going to be 8%, because the first two, as we said at the beginning, spot the difference basically. 2 out of the 3 are the same, one of them is not, and we've already found out the 2. But just to get the learning done, 8%, let's convert this. So converting decimal percentages to fractions to decimals. So 8%, 8%. So per is out of, cent is 100. So 8 out of 100. That's your fraction. And then as a decimal, well, the rules using 100 or any number with a 0 at the end, 10, 100, 1,000, I mean, those numbers. The rules are you can just move the decimal point left or right, depending on what you're doing. So if the operation is multiply, you're making it bigger by that many times, depending on how many zeros there are. If it's divide, you're making it smaller by that many times. In this case, we're making it smaller by 2 times. So moving the decimal point, we're not even making it smaller by 2 times. We're just moving the decimal point 2 times. That's what I mean. So we're moving the decimal point 2 times. And is it left or right? Well, it's going to go left because we're dividing. Okay. So we're going to have 0.08 as this answer here. So 8 over 100 is 0.08. And as you can see, 0.8 and 0.8 is 10 times bigger than 0.08.